Welcome to another episode of Trivia with GK Benefits. Today, the 14th of March, can be written down as 3.14, meaning third month, 14th day. It's that day, beloved of fun-loving mathematicians everywhere in the world, cause it's Pi Day. And we all know that pi is denoted as 3.14. By a happy coincidence, it is also Albert Einstein's birthday. Pi Day was started in 1988 by physicist Larry Shaw at the San Francisco Exploratorium. On March 11, 2009, almost 21 years later, the US House of Representatives passed a resolution claiming March 14 to be celebrated as National Pi Day every year. What an appropriate day to know more about the concept of pi. Everyone has already or soon will learn about pi, which in due course will shamelessly be relegated to the crevices of our memory as a figure of 22 by 7 or 3.14. Is the world of math just about equations, or does it explain things in that mysterious universe and explain things around in daily normal life? Most schools teach facts because knowledge of facts can be tested. Fair enough. But the connection between the beauty out there in the world and the work that's happening in here in class is sadly lost in most schools. What inspires children, though, is the bigger picture. Without applicability, facts and equations are so much dust under the desk. So let's try to truly appreciate the mathematical concept of pi on Pi Day. Succinctly, pi, which is written as the Greek letter this, is a mathematical constant that is the ratio of a circle's circumference to its diameter. This produces a number, and that number is always the same. However, the number is rather strange. The number starts as 3.14, 159, 265, 358, 793 and continues without end. Numbers like these are called irrational numbers due to their infinite decimal part, and it is useful to have a shorthand for this ratio of circumference to diameter of a circle, and hence pi got abbreviated to 3.14. Use this QR code to see an animated explanation of how pi can be found by using a circle with a diameter of 1 unit. The circumference of this circle is pi. Pi has been known for almost 4,000 years. The ancient Babylonians calculated the area of a circle by taking 3 times the square of its radius, which gave a value of pi equals 3. One Babylonian tablet from about 1680 BC indicates a value of 3.125 for pi, which is a closer approximation. The Rhind papyrus of 1650 BC gives us insight into the mathematics of ancient Egypt. The Egyptians calculated the area of a circle by a formula that gave the approximation value of 3.1605 for pi. The first calculation of pi was done by Archimedes of Syracuse around 287 to 212 BC, and he was one of the greatest mathematicians of the ancient world. A similar approach was also used by Zhu Zhongzi, a brilliant Chinese mathematician and astronomer who calculated the value of the ratio of the circumference of a circle to its diameter to be 355 by 113. Mathematicians began using the Greek letter pi only in the 1700s. In the 18th century, Georges Louis Leclerc, Comte de Buffon, determined that you can approximate pi by dropping needles on a grid of parallel lines whose spacing is greater than the length of a needle, and then calculating the probability that they will cross a line. The probability is directly related to pi, as you can see here. According to Beckmann's A History of Pi, the Greek letter pi was first introduced for the ratio of circumference to diameter by William Jones in 1706 AD, probably as an abbreviation of the word periphery. The use of the symbol was popularized later by Leonhard Euler, who adopted it in 1737. By the start of the 20th century, about 500 digits of pi came to be known. Over time, with computation technology advances, in 2021, researchers from the University of Applied Sciences in Switzerland have calculated pi more accurately than ever before to the 62.8 trillionth digit. Pi is most commonly used in certain computations regarding circles, but pi also connects the diameter or radius of a circle with the area within the circle. And we all know these, right? To find the circumference of a circle, we use the formula 2 pi r. And to find the area of a circle, we use the formula pi r square. The properties of pi have allowed it to be used in many other areas of mathematics besides geometry and study of shapes, like complex analysis, trigonometry, and series. For example, in this sum of the infinite series, we can see how pi has been used, or in the Stokes' law in fluid dynamics, or in Euler's engineering buckling formula, and for a final example in Einstein's field equation in cosmology. Time now for you to try something with pi. Using a compass, draw a circle. Take one piece of string and place it on top of the circle exactly once around. Now straighten out the string. Its length is called the circumference of the circle. Measure the circumference with a ruler. Next, measure the diameter of the circle, which is the length from any point on the circle straight through its center to another point on the opposite side. The diameter is twice the radius, which is the length from any point on the circle to its center. If you divide the circumference of the circle by the diameter, you will get approximately 3.14, which is pi, no matter what size of the circle you draw. A larger circle will have a larger circumference, hence a larger radius and a larger diameter, but the ratio will always be the same. If you could measure and divide perfectly, you would get a long series of numbers following the decimal point. Now that's pi. That's all for now. Have a good pi day and try to find pi in the pizza you may like to enjoy today.